Okay, I'm going to do some 1.5 review problems here. Our first problem is dealing with sets. If we have the set A equals the set containing 1, 3, 5, and 7, and B is the set containing 1, 2, 4, and 7, what is A union with B? Now, A union with B is all of the elements from both sets, and we don't list repeated elements twice. So for A union B, we have the set containing 1, also 2, 3, 4, 5, and also 7. Now for the intersection, A intersection B, we only include the elements that are in both sets. So we have a 1 in both sets, and we have a 7 in both sets, and that's it. So A intersection B is just the set containing 1 and 7. Okay, our next problem deals with the notation. Write the statement, all real numbers greater than or equal to 8 but less than 12 in set builder notation and also in interval notation. So we're going to do both notations here in one problem, kind of kill two birds with one stone here. So the set builder notation always starts with this curly bracket, x, and then this vertical line, which means such that. X such that. Now, we could write this in several different ways, but the best way we could write this is 8 is less than or equal to x, but x is less than 12. And then with our other bracket, we could have written x greater than or equal to 8, comma, x less than 12, but this is actually a better way to write it. So that's the set builder notation. Now the interval notation is similar. It has a left endpoint and a right endpoint, and this is why I wrote it this way, because it kind of lends itself to the interval notation. The left endpoint is 8, the right endpoint is 12. That's our interval. Now for this notation, if we're including the left endpoint or the right endpoint, we use a square bracket. If we're not including an endpoint, we use a round bracket. So we have a square bracket to the left of 8. That means that our interval starts at 8 and includes 8, and it goes up to 12, but it does not include it, so we use the round bracket. So that's the interval notation. Square bracket 8, comma, 12 with a round bracket to the right. Okay, our next problem's like number 5 of the homework. Graph the interval notation that gives the interval x such that -5 is less than x, which is less than or equal to 2. Graph that interval on the number line and also give the interval notation for that. So our set builder notation here is telling us that x is between -5 and 2, but the interval does not include -5, it goes up to it. Now you may have learned for graphing this you'd use an open circle. What we're going to do instead is use that round bracket to indicate that we're not including -5. And then at 2, we have our square bracket. So now we have the graph. The interval notation follows that graph that we just did. The interval notation has the round bracket, -5, comma, 2, and then the square bracket. You see how the graph matches that notation really nicely? So and that's one of the reasons we graph this way with the brackets rather than open and closed circles. Okay, our next problem is very similar to the one we just did. Graph the interval given by the set builder notation x such that x is less than or equal to 4 on the number line. So we graph this on the number line. Our interval starts at 4 and goes to the left. And we're including 4, so I use the square bracket. And we shade all the way up to the arrow. Now, the interval notation that matches this, we have a 4, a square bracket, comma. There is no left endpoint, so we have negative infinity and a round bracket. We use a round bracket because you never can get to negative infinity. It just goes on forever. So there's your interval notation that matches this graph. Okay, in our next problem, we're going to write the interval notation round bracket 3, comma 8 square bracket in set builder notation. Now, this interval is telling you that x goes from 3 up to 8, but it includes 8, does not include 3. So our set builder, you always have the squiggly bracket x line. It always starts that way. So our interval goes from 3 to 8. So it's 3 less than x less than or equal to 8. And that's your set builder notation. And let's try one more problem here. Write the interval notation square bracket -5 comma infinity in set builder notation. So the same type of problem, except here we have this infinity that we're dealing with. So now we could write this bracket x line x such that. Okay, now one way we could write this is -5 less than or equal to x less than infinity. Now that would be correct. However, a better way to write this is, I always have a hard time with these squiggly brackets. X such that if -5 is less than or equal to x, that means x is greater than or equal to -5. And that's actually a better way of writing this answer. It's just, it's a little awkward to have this double inequality with infinity. In this case, just write it that way. Either answer is correct. Okay, and that's it with this review, and we'll see you in class.